We're going to begin thinking about rotational motion, specifically, let's say, going around in a circle. And so if we start with a starting point and we were to make one complete revolution or complete a circle, and if we were thinking about that in terms of degrees, well, we would say that we have traveled 360 degrees. Now, there's another measure called radians. So degrees can help us in some things, surveying, navigation, such as that. But many other times we need to be thinking about radians. So again, if we're traveling around in a circle, and we're talking about the circumference of a circle, and let's say our radius is 1, then we have traveled a distance of 2 pi. So there's a relationship, 362 pi. There's also another relationship, but halfway around a circle is 180 degrees, and halfway around a circle in terms of pi is just 1 pi. And from that, we can develop a conversion ratio to convert degrees to radians and radians to degrees. So let's take a look at what we're talking about here. So here we got a measure of 210 degrees, and we're asked to put that into radians. And so we're going to use a conversion ratio. So we're going to multiply this 210 by a conversion ratio. Now, in our numerator, that should always be, if we're using a conversion ratio, that's going to be what we're trying to convert to over what we're converting from. So we want to convert to radians, which are measured in terms of pi. And so I'm going to have pi over 180, what I'm converting to over what I am converting from. Now, if I think about pi and 180, both of them are halfway around a circle, and so they're actually equivalent measures. Pi, 180. If I'm going around a circle halfway, 180 degrees, that's the same as traveling a radian measure of pi. So they are equivalent, and that's how we establish this as a conversion ratio. And it's always, again, in your science classes, anytime you're facing a conversion ratio, what am I converting from over what am I converting, what am I converting to over what I'm converting from, what I'm converting to over what I'm converting from. So we would have 210 degrees times pi over 180, our conversion ratio to convert to radians. So let's see, before I begin this, well, I think I can do a little bit of simplification. Both 210 and 180, I could factor out 30. So if I take 30 and divide it into 210, I'm going to go 7. And if I take 30 and divide it into 180, it's going to be 6. And so 210 degrees then is going to convert to 7 pi over 6 radian. And we know that that would actually be, as we're getting ready to study in a unit circle, that's going to put me in the third quadrant of a coordinate plane, because 180 plus an additional 30, 7 pi over 6. And that would be it. And I'll talk a little bit about more about these radians as we move along. Tempted to right there, but I think I'll pause. All right, so now I've got a negative 60. That means we've traveled clockwise, not counterclockwise, negative 60 degrees. But again, I'm going to convert that into radians, and so I'm going to use my conversion ratio, pi over 180. And again, I'm going to say negative 60, negative 180. Well, I could factor 60 out of this. Could do negative 60, but I don't think it would matter. So 60 will go into negative 60. Negative 1 times. And 60 will go into 180 3 times. And so to convert negative 60 degrees into radians, then I would just end up with negative pi over 3. Now the opposite's true. My conversion ratio again is going to switch if I'm converting from radians to degrees. So again, it's what do I want to convert to? Well, this time we're converting from radians to degrees. So I'm going to convert 2 degrees, 180. That's what I'm converting to, over what I'm converting from. Okay, and that's an equivalent ratio. 180 and pi are equivalent as we're thinking about rotational motion. So let's do a little bit of simplification. Well, my pi's are going to cancel. And I can divide 3 into 180. So this is going to be 1, and this is going to be 60. And 4 times 60 is 240. So 4 pi over 3 radians is going to convert to 240 degrees. Now this next radian measure, you might not quite see it, may have need a little space. That's actually negative pi over 6. But again, I'm going to use the same conversion ratio. What am I converting to? I'm converting to degrees, 180. What am I converting from? Radians, pi. Well, my pi's are going to cancel. This leaves me with negative 1. And let's see, 6 will go into 180 30 times. And negative 1 times 30 is negative 30 degrees. All right, well, shazam. There we are, converting degrees to radians, radians to degrees. We got a conversion ratio. If we're going from degrees to radians, my conversion ratio is pi over 80. If I'm going from radians to degrees, my conversion ratio is 180 over pi. I like pi. What's your favorite pi? Probably not this type of pi. I don't know, though. You might like this type of pie better.